Greetings from Techolution. My name is Rob Massey, Techolution's Director of Public Sector, and joining me today is Ethan Henley, one of our AI customer engineers. Today we want to walk you through a very common use case and solution that we see among our government sector customers. It involves a combination of data fragmentation, search, and result generation. So here we go. A lot of our customers work on problems that involve sifting through multiple files to connect data and then display that data in an easy to manage format, such as a spreadsheet table. This problem is easy to solve if we're working on two files that have all the information we need, and those same files can be easily located. However, for large organizations, this is almost never the case. So let's take a very simple example and problem that comes to us from the US Army. What you're looking at on the bottom half of your screen is an officer evaluation report, or OER. Every officer in the Army is required to have one of these completed on at least an annual basis. And so what you're looking at, though, is the end product. This is actually created from a worksheet called an OER support form, which is what you see on the top half of your screen. So now we have two documents sitting in our file repository, and those documents are linked. And so as you can see, we've simplified this problem by just showing you the two linked documents. But imagine a repository that contain hundreds of thousands of these documents. Even if we try to search through that repository using keywords, we'll be lucky if we can find the files we need. And even if we do, we'll then have to extract from those files the needed information display in a table formats that our workforce can actually use the information. So at this point, I'm going to turn it over to my customer engineer, Ethan Henley.
Thank you, Rob. Let's dive into our solution approach to this problem. If we have a folder filled with files with no conventional naming conventions, how do we find files that are related to each other? Well, instead of spending time going file by file, we approach this problem by using the content of each file to create a context basis to search for them. So we start with your PDF documents. These could be in any object storage, it could be a cloud, server, wherever, and we use our AI document processor to parse through these files, finding keys and their associated values. A way to think about this is that on any form, you will have a field and a response to that field. Our AI grabs the information and it stores it in a data warehouse to be easily retrieved later. The way we retrieve it is by using a matching engine. Say I have a file and I want to find all related files very easily. I use that file name as a prompt, and our AI is able to search through the data warehouse with all that context and find its related files. So let's see this in action. For the purposes of this demonstration, we are going to be investigating this problem approach using the Google Cloud Platform. Now, it is important to know that Techolution is completely model and cloud agnostic, so we can meet our customers wherever they are. We are just using GCP for this demonstration. So as you can see here, we have a data bucket with two folders, OER and OER support. These support forms are made to build the main OER forms. So if we take a look here, we should see that there are lots of fields here, and this is just redacted so I could show you all, but in the actual bucket is not redacted. These fields will match a lot of the fields seen on this main OER document. Now, these fields can be used with DocAI to extract key value pairs and help me easily find corresponding documents. Now we're going to live in a notebook. Here we have built out some code that uses DocAI to parse through our data bucket and create a BigQuery table with the detected key value pairs. This created dataset makes it possible to easily and quickly extract related documents. So when we go down to our execution function, we can see that all I need to input is a file name. Now, when I put in this OER 2015 main OER document, I would expect that it returns the support document related to it. So when I run this code, here's what it returns. Just like that, we've returned the OER support document. Now, I could use that as input, and I would expect it to return the main document because they're both related with many of the same fields. Just like that, we got the main OER 2015 document, which we expected because it is related to our 2015 OER support form. There was no need to go file by file. All our AI needed was a folder of PDFs, and it was able to automatically return these related documents.
Thanks. So what Ethan has just shown you is how we can search through a repository of similar documents and find those documents that are linked, saving our workforce countless hours looking through the haystack to find those handful of needles that are somehow connected to one another. And now that we've done that, because we can read through these forms like a human being would, we can then extract the necessary information from those documents in some sort of usable format that our workforce can actually leverage. In this case, we're just using a simple record that we've created and placed into a spreadsheet of some kind. And we can certainly customize the fields and the information contained within those fields that we want to find. So for this particular example, we've just pulled some information from one document, as well as some information from the other document that it was linked to. And we know that the solution did this correctly because the officer evaluation report support form, the worksheet that's used to create the report, indicates that the last evaluation through date was on June 15th, 2015. It's connected to the evaluation report that begins on the very next day, which is June 16th, 2015. So now what we've done is we've created a simple record that contains data from forms on multiple documents. So again, imagine how useful this could be if you're trying to extract information from, again, multiple documents that are somehow connected together through a contract number, maybe a customer name, all kinds of different ways to link documents, but then extract the information in those documents into some sort of usable format.
We see use cases like this all the time, especially in the public sector space. Government contracting is one of many such use cases. Oftentimes, you may have a contract with multiple linked documents, such as KPP metrics, equipment specifications, part numbers, requirements, deliverables, dates, etc. And all of this information will be scattered across multiple documents. Here, what you're looking at is a government solicitation, and it's asking us to submit a response that addresses the requirements in a statement of objectives. And that statement of objectives is a separate file. So where is it? And what are those requirements? Well, they're here, but I knew that well in advance. If you're working with multiple solicitations that you have to respond to and multiple linked documents, it's never going to be this easy. And so the solution that we've demonstrated for you here today is capable of generating that information across scattered documents at a scale and speed no employee can compete with. But it will allow your workforce to move quicker to help your organization deliver results at the speed of relevance. Thank you for listening to our demonstration here today. We look forward to delivering real-world AI solutions for your team.